The answer to number 1 is choice 4. So if you look at what I did here, I just circled the pi over 3. You should know that pi over 3 is 60 degrees. So what this question is really asking, sort of, is what's the sine of 60 degrees? And what I like to use to figure out what the sine of 60 is this little tic-tac-toe chart. So I make like a little tic-tac-toe 3 by 3, and I go in SOHCAHTOA order. So ka, toa down the left here. Then these are our special angles, and I go in numerical order from least to greatest. And just a reminder, if you've done this, if you haven't done this, then I'm going to show you. There's a little trick. You just need to be able to count to 3. So 1, 2, 3, 3, 2, 1. Pretty easy, right? Okay, then what we're going to do is we're going to make denominators or fractions out of all of these. So we go 1, 2, 3, 3, 2, 1. Then every single denominator is going to get a 2. And then every numerator is going to get a radical. Now notice I skipped over the 1. You can put a radical here and a radical here, but the square root of 1 is 1, so I don't tend to write it. So just to backtrack, SOHCAHTOA order, numerical order from least to greatest. Then we did 1, 2, 3, 3, 2, 1. All the denominators are 2's, and all the numerators get radicaled. All right, so that leaves these guys. There isn't something quite as catchy as what I just did, but I'll show you what I do have anyway. I put a big 1 in the middle. And then on either side, I have a radical 3. And then lastly, I look at these radical 3's, and they correspond to 30 and 60 degrees. 30 has a 3 in it. 60 does not. So 30 has a 3 in it. That gets an extra 3. That's how I remember it. I don't know how else to tell you to remember it. So big fat 1 in the middle, both radical 3's. The angle measure with a 3 in it gets an extra 3 in the denominator. Okay, so that was a very long way of asking what's the sine of 60. So if I look over here, sine of 60 is radical 3 over 2. Your calculator is not going to give you radical 3 over 2 no matter how hard you try. It will give you a decimal equivalent, but that's not going to help you because if you look here, we don't have a decimal. Okay, so I know that the answer will be some form of radical 3 over 2. So I know it's not choice 1 or choice 2. But then you see that we have a negative and we have a positive. So let me go back here. This really isn't completely the sine of 60. There's an 8 here that I ignored. Okay, and what I'm supposed to do with that 8 is multiply that 60 by that. Okay, so when I do that, I'm going to get 480. So what this question was really asking for was what was the sine of 480 degrees. Okay, for our purposes, I'm going to show you why we really only needed to know the sine of 60. All right, so I know that 480, if I were to rotate that, is a full 360 around and a bit more, and I'm not really sure how much more, you know what I mean? So what I'm going to do is I'm going to do 480, subtract 360 from that, and I get 120. So that means my angle puts me right here into this second quadrant, okay? Because I'm starting here. This is 90, 120 is somewhere in here. So my angle of 480 degrees is in the second quadrant. Remember, there's that little saying, all students take calculus. And because I'm in the second quadrant, I'm looking at this fact, and the sign in the second quadrant is positive, which means my answer here is positive. And that's why the answer is this. Okay, let me just go one quick step further. Let's say here when I subtracted, I'm completely making this up, so it's a completely different question, but let's say I had gotten, I don't know, 200 degrees instead of, here, let me put my pointer on. Instead of, when I subtracted here, instead of getting 120, I get 200. So 200 degrees, there's 90, there's 180. 200 would be in this quadrant, okay? And tangent is positive in that quadrant, but we're dealing with sine. So if I had something where I had a 200-degree angle and sine in the third quadrant, my answer would be a negative radical 3 over 2. It would have been that one. Okay, so that's where this 8 comes into play, because when we multiply through, we figure out what quadrant we're in. And all that quadrant is going to help me determine is if I have a positive here or a negative here. Okay? Number 2 is choice 1. An experiment, anytime you're doing a random assignment, 2 groups, one group, something happens, but the other group, the opposite happens, that would be an experiment. Okay, number 3, the answer is choice 2. You can mathematically cheat on this. You can pick a number. I like 2. Oops, we're going to do store as X, hit enter. Okay, and then after that, all you're going to do is type this in. You'll get a number, a random number. Then you plug in all 4 of these choices and see which one of these choices gives you that number that you got when you plugged this in after you stored 2 as X, and this one matches. Number 4, the answer is choice 2. Okay, so a couple of things. Please remember that when you see the y value for f equal to the y value for g, whenever you see one function is equal to a different function, in your answer, all they want are x values. Okay, they don't want y values. So in that case, choice 1 is out because 0.75 is an x value and 0.4 is a y value. I'm sorry, 4 is a y value. Same thing with -2 and -1.5. All right, obviously, choice 3 is also out because that's got y values. And actually, so is choice 4 because this is a y value. So boom, there's your answer. Now, I cannot guarantee you that when you take a Regents that that's going to happen. Sometimes what they will do is put more than one answer choice that has just x values, like choice 2 does. So to be on the safe side, I put this into my y1, I put this into my y2, and then I hit second calc, which is your trace button, and I went down to number 5, I believe it is, it says intersect, and go ahead and do the intersection, and you'll see that you'll get x equals 0.75 and x equals -2. Number 5, the answer is choice 1. So they're asking for the quotient, which is what that means is you need to do your long division. All right, so remember, we start with, what do I multiply this by to get to our first term? So this would be 2x squared. Then remember that we take this 2x squared, anything that will go up here, we will take this multiplied by the first term, multiplied by the second term. Okay, so that gives me 2x cubed minus 6x squared. I am going to subtract those. So I've got 2x cubed minus 2x cubed. Those should always cancel out, these first terms, so those are gone. Then just be a little careful here. So I have -3 minus -6. -3 minus -6, which is a positive 3x squared. Bring the next term down. All right, so we repeat what we did the first time. So what do I multiply this by to get the first term here, which would be 3x squared. And that would give me a positive 3x. And then remember what I said before, anything you put up here, you have to multiply by this term and write it underneath. Okay, so that's going to give me 3x squared minus 9x. And I'm going to subtract that. These guys will cancel out. And then I'm going to have negative 5 minus negative 9, which will give me a positive 4x. And I bring down the next term. And lastly, what am I multiplying x by to get to this 4x? And that would be a positive 4. And I multiply that 4 by the x and the minus 3. So that's going to give me 4x minus 12. And when I subtract, everything cancels out. So that's why your answer is choice 1. Number 6, choice 1. Number 7, the answer is choice 2. If you look at all the answer choices, maybe except for number 1, they all look pretty complicated. So I know I'm going to be doing quadratic formula. And I know I have a quadratic because I have a squared term. And when I have a quadratic, when I have a squared term, I always want to get everything to the side of that x squared and set it equal to 0. So then in this case, I'm going to add 10 here and add 10 here and get rid of that. So that's going to give me 4x squared minus 7x plus 8 equals 0. You have the quadratic formula. It's on the formula sheet. Okay, so something that I want to really point out is right here. Please be careful. That's a negative 7. And according to the formula, we should be doing b, which is negative 7 squared. When you put it in your calculator, you must put parentheses around that negative 7. If you don't, and you don't have parentheses and you just type in negative 7 squared, it's going to give you negative 49, and that's not the answer. What we're doing is we're taking negative 7 and we're multiplying it by itself, which is negative 7 times negative 7, which will give us a positive 49. So please be very careful when you put this in the calculator. Now, I would not put the radical in the calculator. Just type in everything underneath exactly as you see it. And then you should end up with negative 79. Okay, now I know that if I have a negative underneath the radical, that means we have an I. And 79 doesn't break down to 2 factors where one of them is a perfect square. So I'm just going to leave it like this. And then if you look, that is the same answer. Because if I were to split this up, here's that 7/8 that's in choice 2. And then here's the radical 79 I over 8. Number 8, the answer is choice 3. If x minus 5 is a factor, that means x equals 5 is a 0. Okay, and what that really means then is when I take the p equation and I plug in 5 for x, I should get 0, and that's what choice 3 says. Number 9 is choice 3. Okay, so I underlined the key phrases there. So they give you a mean, they give you a standard deviation, but then down here they talk about that middle 95%. Remember that formula is the mean plus or minus 2 standard deviations. So what I'm going to do is I'm going to start by doing the mean minus 2 standard deviations, which would be, let's see, the mean is $2.12 minus 2 times the standard deviation, which is 0.05. And when I do that, I get 2.02. And then I'm going to do the mean plus 2 standard deviations. So again, the mean is 2.12. And this time I'm going to add 2 times 0.05. And I will get $2.22. And there's your answer. Alrighty, so the answer for number 10 is choice 1. It says is equivalent to. Remember, when it says that, they are giving you one expression and they're saying one of these is equivalent. In other words, it's the same. It might look different, but it's the same as this guy. So when that happens, I like to, I did it in one of the other ones, to store X, enter. And then after that, type in this expression right there. You'll get an answer. And then if you type in this one, you should get the same answer. That's how you know you got it right. If you typed in any of these, you won't get the same answer. All right, number 11. The answer is choice 3. Oh, look at this phrase, is equivalent to. So that's the same thing as number 10. So you type this in your calculator exactly as you see it. You'll get an answer. Then you'll type in this one and you will match the two together and you'll see that they're the same number. Number 12, the answer is choice. Whoops, put my pen on there. The answer is choice 2. Okay, now I know it says is equivalent to. To be honest with you, I don't know how to mathematically cheat on this one when we have i's. Okay, so I'm not going to mathematically cheat for that. Now, I do know that I squared is -1. If you forget, hit your calculator and you can do second, then the decimal button. Okay, and you'll see the I will come up and put it to the second power and you'll get -1. So I'm going to replace that I with a -1. And then I'm going to write 5x minus 2i. And when it's squared, that means we write that same exact thing twice. And now I'm going to double distribute. I'm just going to keep this -1 for right now. I'm going to use a bracket. You could use parentheses, it doesn't matter. So that's going to give me 25x squared. Then this will give me -10xi. And then I'm going to do this guy, and that's going to be another 10xi. And then I'm going to do these guys. A negative times a negative is a positive. 2 times 2 is 4. I times I is I squared. Okay, so let's see what we can do here. So -1, oops, I guess I should bracket that, right? All right, I'm going to change them to parentheses. They're interchangeable, doesn't matter. So 25x squared, I'm just going to leave as is. Now these guys right here are like terms, so I'm going to add those, and that's going to give me -20xi plus 4, and there's that I squared again, and I know that that's -1. Okay, so I've got -1 times 25x squared minus 20xi, and then this is going to give me -4. All right, now here's where this -1 comes in. I'm going to distribute that through to everything. So that's going to give me a -25x squared plus a 20xi, and then plus 4. Number 13, the answer is choice 2. Okay, so it says when 2 f of x's. So in other words, I have to take this and I'm going to multiply by 2. So I'm going to distribute that 2 through every term there. So when I do that, 2 times 7/2 is 7x squared minus 10x plus 22. So there's your 2 f of x. And that 2 times f of x is subtracted from, be careful, subtracted from means you're writing g of x first, then this guy second, okay? So I'm going to write g of x first, which is 3x squared minus 7x plus 25. I'm going to put that in parentheses, and then I'm going to subtract my 2 f of x, which is 7x squared minus 10x plus 22. And I'm going to distribute that negative through. So I keep this guy, 3x squared minus 7x plus 25. Then I get minus 7x plus 10x minus 22. Okay. Oops, I forgot the squared. Got the squared. All right, so now I'm just going to add like terms. And so I see that these guys both have x squareds. So that's going to be negative 4x squared. And I see that these guys here both have x's. So that's going to give me plus 3x. And then lastly, the 25 and the negative 22, those are like terms as well. And that's going to give me plus 3. Number 14, the answer is choice 3. When you see normally distributed, mean, standard deviation, they usually will be asking for a percent, or sometimes they'll ask for how many. They'll say how many and then refer to, whatever they're talking about in the question. But then you see this phrase between, and in this case, two numbers. Sometimes you'll see less than or more than. We're not going to go into that right now. But again, normally distributed, mean, standard deviation, and in this case, between two numbers, that's your normal CDF. Okay, so you hit your normal CDF button, which is second bars, which is your distribution button, and it'll say DISTR. Okay, you hit that, and down at number 2 is the normal CDF. All right, so then what you do is that it's going to say lower. Well, your lower number is 7.9. Your upper number is 8.11, right? Because we're between 7.9 and 8.11. So 7.9 is the lower one, 8.11 is the upper. Then you're going to see this funky symbol. That's your mean, okay? We know it as x with a bar over it. So then you're going to put that in, which is going to be your 8.0. Then you'll see this symbol, that's your standard deviation, which is 0.04. And then you just keep hitting enter, enter, enter. Okay, and when you do that, you're going to get 0.9908. And if you write that as a percent, that will be 99.08%. And they rounded that to the nearest tenth. All right, 15. The answer is choice 4. This is tricky. Usually you can put this in your calculator by doing your second matrix button, which I love to do, but I am going to show you what you have to do in order to put it into your matrix button and get it right. Okay, so this first equation, no problems whatsoever. X comes first, the Y comes second, the Z comes third, then there's an equal sign, and there's a negative 14 or a number afterwards, okay? We don't have that in the second one. So you cannot hit that second matrix button until you get that equation looking like the first one. So there's no X here. Okay, not hard. Watch this. If there's no X there, all you have to do is write no X. How easy is that, right? So then I'm just going to copy down the 7y, the minus Z equals 31, and I'm done. Isn't that great? Okay, so if you're missing a letter, just put 0 and then whatever letter you're missing. Here's the thing that you got to be very careful of. If X goes first, Y goes second, Z goes third, then you must have X, then Y, then Z here as well. The reason why I'm saying that is look at this. They messed with you. This is not first, and that's supposed to be first. X is always supposed to be first. Okay, so we're going to switch it. No big deal. So I'm going to put X first, and my X is negative 5X. So I'm going to write negative 5X. Then I'm going to put my Y second, which is a positive 5Y. And I'm going to put my Z third, which is a positive 4Z. And then I just write equals negative 23. Okay, now go to town, do all your second matrix stuff, get your answer, and you will see that, what are they asking for? The value of X in the solution? You'll find out that the value of X truly is negative 7. The answer to number 16 is choice 1. So the question asks for the daily rate of decay over an 8-day interval is approximately, and then it's one of obviously these 4 choices. right? So it says, though, that this graph is showing the amount of radio substance left over time, okay? So this is a rate of decay, but we want to figure it out with respect to this graph, which is referring to an amount that's left. Okay, so remember there's a formula, and that's y equals a. Oh, hold on a second here. What am I doing? Try that again. It's a equals p times 1, and it's either plus or minus, and since we are decaying, it's minus r to the t power. Okay. Now, if you look here at time 0, we're starting with 50. So this amount is going to be 50. And so what I did was I made an equation for each answer choice. So for number 1, what I did was I said a equals or y equals, it doesn't really matter. We start with 50. Now the rate of decay is 23%, but because the equation or the graph that we have here is referring to how much we have left, if 23% decays, then 77% stays. Okay, think about that. 23% decays, so then 77% would be remaining because these two add up to 100. So I'm putting in 0.77 to the x. And I would do the same thing for every single one here. So y equals 50. Now, if the decay rate is 95%, then the amount that remains would be 5%. Okay, and then this guy right here would be y equals 50. If the decay rate is 5%, then the amount remaining is 95%. And lastly, then this one is y equals 50. And if 77% decays, then that means we have 23% remaining. Okay, now you may be asking me, what the heck am I doing with this? So what I did essentially is, well, I didn't have to go too far, but I plugged this into my y1, and then I went to the table and I matched at x equals 0 was y50. Okay, which should really be the case on all of these, but then I looked at the rest of the numbers. So for example, if this is day 8, this would be day 1, 2, 3, 4, 5, 6, and 7. So at 1, then I figured out approximately what this y value was, and I noticed that that matched what was in my calculator. Okay, the y values at 1, the y values at 2, and so on and so on and so on, matched this equation when I went to its table, whereas these didn't match at all. So that's why the answer is choice 1. Okay, so number 17, the answer is choice 3. Okay, so they want you to find x, which means I need to get x by itself. So I'm going to just start by dividing both sides by 4. And then I'm just going to put it over here because I have more room. So when I do that, I'm left with 10. And then I've got 2 to the 5x minus 2 equals, and then 12 divided by 4 is 3. You should remember that when you're trying to find an x, but it's an exponent, we can bring it down in front. But remember, we have to log the 10 and we have to log the 3. So that's what we have to be a little bit careful of. So I'm going to log that 10. I'm going to log that 3. And then this 5x minus 2 is going to go down in front. Okay, so let's just rewrite that, make that look pretty. So we've got 5x minus 2. It's a binomial, so I'm just going to put it in parentheses so it looks a little less confusing. Log 10 equals log 3. See, now everything, we're kind of like on an even playing field here because everything is all on one line, as opposed to here where it was an exponent, right? Okay, so now I'm just trying to get x by itself. So I'm going to start by dividing out that log 10. So log 10, that disappears. So I've got 5x minus 2 equals, okay, so here's the thing. If you were to put log 10 in your calculator, do it right now. If you put log 10 in your calculator, you should get 1. So this then really is just the log of 3 over 1, which is really just log 3, right? So I'm going to write this as log 3. And then I'm trying to get x by itself, so I'm going to add 2 to both sides. So I've got 5x equals log 3 plus 2. And then I'm dividing out that 5. And now you see that matches choice 3. 18, the answer is choice 1. What I did was I looked just at choice 1, which, obviously is the answer, but I obviously didn't know that at the time. So I underlined the important things. So the first thing that it says, the probability of being late given the student walks is greater than the probability that a student walked given that the student was late. So you can see that they took this being late statement and that student walking statement, and then you just flip-flopped it down here in red, okay? So what I did off to the side was, I was like, all right, well, let me just start by finding whoops, there goes my pen. Let me start by finding the probability of late given walking. And then let me find the probability of walking given late. All right, so let's look at this first one right here. Probability of late given walking. So I always say, look at this last statement here after the given symbol, that's your denominator. So this would be your denominator down here, walking. So if I go over here, I look and here's my walking right here. So there's 22 people altogether that are walking. So I know that my denominator here is going to be 22. And I'm just going to, I like to do this when it's in a table. Because now what you're going to do is you're going to look at these 22 people, and of these only, look at these 22 people, how many of them were late? And you can see that there was 4. Okay, so this is 4 over 22. Okay, and just, I put this in my calculator and that's 0.1818. Okay, so you're going to do something similar with this guy, except that late comes after the word given, late. So let me just kind of go back here. Oh, that doesn't let me do that, does it? All right, I'll do it in a different color. I'll do it in red now. All right, so late. So I'm looking at the people that were late. Let's just look at these 3 numbers and you add those guys up and you see that there are 30 people that were late. Now, of these 30 people, how many walked? So you can only look at these numbers. How many of them walked? That would be 4. Okay, so we're just going to go ahead and we're going to throw 4 over 30. And then I have 0.1333. So now let's go back and let's look at choice 1. It says that the probability of being late, given that they walked, that's this one right here, is greater than the probability of a student walking given that they are late. That's this one here. And do you see that 0.1818 is greater than this guy? So that's why the answer is choice 1. Number 19, the answer is choice 2. Okay, remember that this means inverse. And all inverse means is to take your original equation and switch x and y. So in other words, this is y. In the inverse equation, I'm going to make it x. And this is x. In the inverse equation, I'm going to make it y. So I'm going to start by just going x equals, because f of x is the same thing as y, switch it to x. And then instead of the cube root of x, I'm going to have the cube root of y. And there's my inverse. Problem is, that's not an answer choice. Okay, and when they ask it like this, they're trying to tell you, hey, could you do me a favor? Could you get this equation to say y equals? You want to get y by itself. So I'm going to start by just moving over that 4. So go like this, boom. And then I have got x minus 4 equals the cube root of y. And then I have to get rid of that cube root, right? So the opposite of cube rooting is cubing. What I do to one side, I do to the other. So that knocks that guy out. And there's your answer. X minus 4, that quantity cubed, equals y, which is really your F inverse of x. Okay, this is just a fancy way of saying y. The answer is choice 1. They want you to find out what B is, and if you look right here, B is the letter, or the variable in this case, that represents the number that goes in front of the word, in front of the letter X. Okay, and when we see that, then we should know that that's really asking for the frequency. And they gave you that the period, right here, the period is 12. So remember, there's that formula, period equals 2 pi over the frequency. Likewise, frequency equals 2 pi over the period. Okay, so just try to remember that these letters are interchangeable. So in this case, we're looking for the frequency. So I'm going to use this one, and I'm going to put the period in there. Okay, all right, so let's do this. So we have frequency equals 2 pi. The period they told us was 12. And then all we have to do is, you can either do this in your head or take your calculator, do 2 over 12, and that is going to reduce to 1/6. So that would be pi over 6. There's your answer. 21, the answer is choice 2. So they're asking you to find out which extraneous solution did he find. Remember, an extraneous solution or an extraneous root means an answer to this equation here. However, when you go back and you check it, the left side doesn't equal the right, so we reject that. Okay, so I'm just going to start by solving for x. So I want to get rid of that radical. So I'm going to square both sides. So on the left, I'm going to get 4 minus x, right? Because the square and the square root cancel each other out. And then on the right-hand side, I'm going to do x plus 8 squared, which is the same thing as writing it twice. Okay. So this is going to be x squared plus 16x plus 64. Now, remember, you have a quadratic. You have a quadratic because you've got a squared term. That means all these guys, I want them over here. I want to set it equal to 0 because I will be doing your very favorite thing. And I'm going to be factoring. So minus 4 plus x, and here we go. Those are gone, right? All right, so I've got x squared plus 17x plus 60 equals 0. Now listen, if you don't like this, you can do quadratic formula. It's asking for solutions. So whenever it's asking you to solve or asking you to find roots or zeros, you can do quadratic formula. All right, but I'm not going to. So I'm looking for what adds to 17 and multiplies to 60. So that's going to be, what do I got here? X plus 5 and x plus 12. And then x equals negative 12. Remember, we just switched the signs. And x equals negative 5. Okay, so those are your two answers. Now, what happens is this x equals negative 12 is the one that's extraneous, because let's look at this for a second. So if I do 4 minus negative 12, which is really the same thing as 4 plus 12, right? And 4 plus 12 is 16. And the square root of 16 is 4. Now let's do the right side. On the right side, we had x plus 8. You always go back to that original equation. All right, so x is negative 12 plus 8, and that is negative 4. And you can see these do not equal each other. There's your extraneous solution. Number 22, it says which one is not equivalent. Remember how when I said when you see is equivalent to that you cheat? You do the same thing. You're just going to look for, so in this case, you're going to do 2 store as x, enter. And because we have a different letter, you're going to do 3 store as y, enter. Okay, now remember your y button is above your 1. So you have to, it's in green. So you have to hit alpha and then the 1 button. Okay, so then once you do that, then you're going to type in this expression, and then you're going to type in this one. And you're going to end up getting the same answer. which means this is not the answer because they want to know which one isn't equivalent. And then when you type in this guy, it will not equal what you got when you typed in this guy. So that's your answer. Whereas these, if you were to type these guys in, you will get the same answer as when you typed this in, okay? Because of that word not. Number 23, the answer is choice 4. Okay, you really got to read this one over. Read it a few times. I had to read it a couple of times. Now, they're saying that the trail, I'm reading right underneath the graph, has a minimum height of 16 feet below sea level. So that's this right here, okay? Your minimum, your lowest, is 16 feet below sea level. Let's read the question. It says, which function or functions could represent a running trail whose minimum height is half of the minimum height of the original trail? This is the original trail. So if the minimum height is negative 16, then half of that, its minimum height would be at negative 8. Okay, so we're looking for which of these, or maybe more than one, will have a minimum of negative 8. Got it? Half of this, and half of negative 16 is negative 8. Here we go. Okay, when you have a 1/2 here in front of the x in the parentheses, as opposed to a 1/2 here, which is all the way in front. Okay, this is what we call a horizontal stretch. And I think the easiest way I can explain that is to take a rubber band, and if you take your two hands and you stretch it vertically, right? So you may have a rubber band that looks like this, but when you stretch it vertically, it starts to look like that, right? And the more you stretch it, do you see that this minimum would actually be going lower? Okay, lower than this. And we actually need to be higher than that. So choice 1 is not an option. Okay. All right, let's look at choice 2. It says f of x plus 8. Well, when you add 8, all you're doing is you're taking every point here and you are going up 8. So if I take this point and I go up 8, here, I'll even draw it for you. Okay, not that you need to, but just so you can see it, up 8. Then if I go to this negative 16 and I go up 8, well, now, doesn't that leave me right here? See how it's going to go like this? And this at 2, 0 here, that's going to go up 8 and it's going to be here. So do you see your picture is kind of looking like that? Really bad picture, but you get the general gist that from negative 16, I am going up 8. So that satisfies what the question's asking for. Okay, so check. All right, now this last one here, when it says 1/2 of f of x, this is called a vertical compression. Vertical compression. So it's like you're taking something and you're squeezing it down. Okay, so no, I'm not doing a good job here. Squeezing it. So this is getting squeezed up and this is getting squeezed down. Okay, so it's going to widen this from left to right. Well, if this gets squeezed up, it basically gets cut in half. And again, half is negative 8. So that also is an answer choice. And that's why the answer is choice 4. Number 24, the answer is choice 4. And here we go. They're asking for the total weight of the fish caught. Okay, and we're starting catching fish on Monday and then going all the way through the end of the week to Friday. That's 5 days. So that's your sum formula. You get that, so you don't need to memorize that. Remember, total means sum. Okay, and then you just throw it in. And because we're increasing by 15%, this is 1 plus 15%, which is 1.15. Okay, number 25. A number inside parentheses, you go in the opposite direction of that sign. That's why I shifted left, because that's a plus, opposite direction. Number outside the parentheses, do exactly what it's saying. So in other words, that negative, That's always an up or down, by the way. And since it's negative, we're going down 5. 26, the answer is x equals negative 3. So I need a common denominator here. And if I look at the numbers, I just have a 2 and a 6. So I know I want that common denominator to be 6. I could say 12. That'll work. But 6 is better because everything just stays smaller and then it's, less work for you later on. So, and then I see that there's also an x in there. So if I want to make 2x a 6x, then I know that I need to multiply by 3. But what I do to the bottom, I do to the top. Let me go to the next fraction, 5 over 6. If I want to make that a 6x, then this guy needs an x. What I do to the bottom, I do to the top. And lastly, this last fraction needs to say 6x, so I multiply top and bottom by 6. Once you have this, so once you have the new common denominator, look, 6x, 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 and it's an equal sign, and you have multiplied every numerator by whatever you needed to multiply it by, then you can just go like that. Don't scribble it out to the point that somebody who's grading your test can't see it, but you can cross that out. All right, so then I'm going to just go through and I'm going to multiply these two, and these two. Okay, so here we go. So I've got 3 minus 5x equals 18. And now I'm just going to solve for x. So I'm going to go subtract 3, so that's negative 5x equals 15. And I'm going to divide by negative 5. And there's my answer. X equals negative 3. Okay, so number 27, we are in the second quadrant. I'm going to draw a triangle in the second quadrant. Remember, we always start at the origin. And we shoot out a terminal side into the second quadrant, and we always complete that triangle by going from this point right here always to the x-axis. So this guy is coming down. You've got a right triangle there. Theta, remember where theta is. Remember where it is. It's always in this corner by the origin. And then we have cosine. And remember, cosine is adjacent over hypotenuse. So this is the adjacent and this is the hypotenuse. So if I have theta, adjacent is the side right next to it. So that's a 2. And hypotenuse is right there at 7. Okay? All right, now do you see that I do not have this side? If I have a right triangle, remember I can do Pythagorean theorem. So 2 squared plus x squared equals 7 squared. And then when you take the square root of 45, you want to try to break that down where you have two numbers that multiply to 45, where one of them is a perfect square. So the square root of 9 is 3, and you bring that radical 5 out. Okay, so this is this side right here, x. Okay, all right, so now they're asking you to find the sine of theta. Okay, so sine theta. Now remember, sine is opposite over the hypotenuse. All right, let me do this in a different color so that you can see it a little bit better. Okay, so again, when we're doing opposite over hypotenuse, we're referring to theta right here and saying which side is opposite that. And that's this side right here, which is x, which we know is 3 radical 5. And then hypotenuse, we know, is 7. Okay, last thing, just remember that when we're dealing with the quadrants, we have to take into account all students take calculus. And I'm in the second quadrant right here, and sine is positive in the second quadrant. And they are asking for sine. So our answer here should be a positive 3 radical 5 over 7. Hypothetically, if this triangle was down here in the third quadrant, sine would be negative here, and we would just put a negative in front of that. Okay? But we are in the second, so it is positive, and that is our answer. When they say exact value, that means they want a simplified answer that's in radical or fractional or fractional form. No decimals. All right, so this is going to be a fun one. We had something like this, I believe, in the part 1 section, one of the multiple choice, and we cheated. And as you're seeing right now, we can't always do that because we can't cheat here. So what I'm going to do is I'm going to look at this right here and remember that, do you remember that whole saying, power over root? Okay, so what we're going to do is we are going to take this radical and we're going to de-radicalize it. So we're going to make this a fractional exponent. So I'm going to start with a, and then the numerator will be the power, which is 10, and the denominator will be the root, which is 5. There we go. Over. I'll fix that in a minute. Then I'm going to look at this right here. And remember, when you have a power to a power like that, 3 and then to the 1/2, you multiply. So I'm going to make 3 over 1 and multiply it by 1/2. And you can do it in the calculator, or we're just going to do it right here. So you multiply numerators, 3 times 1 is 3, and then you multiply denominators, 2 times 1 is 2. So that's going to be a to the 3/2 power. Okay, and this is supposed to equal a to the x, and we're trying to find x. All right, so you may say to yourself, okay, well, this is 2, right? Yeah, that's 2. Now remember that when you are doing division and you have exponents with the same base, you subtract those 2. So you're doing 2 minus 3/2 is what you're really doing. So off to the side here, 2 minus 3/2. And I would just do that in the calculator, but that's going to end up being 1/2. And this equals a to the x. All righty. So we're trying to find x. Do you notice both of these base values are the same? So that's an a, that's an a. When that happens and your bases are the same, then really all you're going to be doing is you're going to be taking these exponents and you set them equal to each other. So that's just 1/2 equals x. There's your answer. All right, so they want us to graph at least 1, which means we're graphing 1. Why would we do more? We want 1 cycle of this sine function. Okay, so right there, my frequency is 4. Now, I know that I want to draw a sine curve, and you should remember that a basic sine curve starts at 0, ends at 0, and does 0 in the middle, a basic sine curve. And then we usually go up and then down. So that's what we're kind of modeling that. But remember, there are 1, 2, 3, 4 values that we usually label on that x-axis. And all of these numbers here are messing with that. So I'm not really sure what I'm supposed to put along here, but yes, I do. So what I start with is to find out what you're putting along that x-axis. You start by finding the period. Okay, so the period is equal to 2 pi over the frequency, right? And that frequency is 4. So if I reduce that, the period is pi over 2. Okay, to find what goes along your x-axis, that's called your x scale. X scale, all you do is you take your period and you divide it by 4. So I'm taking my period, which is pi over 2, and I am dividing it by 4. Well, that looks gross, doesn't it? So remember, keep, change, flip. So I'm going to change division to multiplication, and I'm going to flip this 4 over 1 and make it 1 over 4. So that's pi over 8. That's my x scale. All right, so what does that mean? This is what that means. So if I'm putting my first little slashy thing here, I'm going to write pi over 8. Then I'm going to do my second slashy, and I'm going to write 2 pi over 8. Then my third slashy, I'm going to write 3 pi over 8. And lastly, my fourth one, I'm going to write 4 pi over 8. Really easy, right? Okay, as long as you find your period, divide it by 4, because 1, 2, 3, 4 slashies, right? Divide it by 4. That's going to tell you what to name this first thing. That's a 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Okay? All right. Now, the next thing that I really like to look at after I do that is, do I have a shift, a vertical shift? And yes, I do right here. Okay, my vertical shift is always that number at the end. So what we're actually doing, not in parentheses, by the way. So what we're actually doing is we're shifting down 3. So 1, 2, 3, I like to draw, remember when you shift down, that's your midline. So I like to dot that right at that -3. So this is y equals -3. Okay. All right. So now all we have to do is plot the points. Now let's look. We start, middle, and end all on our, here it's our x-axis, but really this is our midline. So I'm going to start, middle, and end all on my midline here. All right, so this is what I mean if you're not following. I'm starting, I'm ending, and the middle is 2 pi over 8. See that? All 3 of those are on that midline. Okay, then go back to what I did right here. See how I went up first here? If this 5, which is the amplitude, is positive, then that means my graph goes up first. If that 5 was negative, then that would mean that from here I go down like that. But since it's positive, I'm going up. How much am I going up? I'm going up 5. So here I am at -3, so I'm going to go 1, 2, 3, 4, 5. That's how high I'm going to be right here, okay? Because I'm looking for the middle of these 2 dots, which is right here, pi over 8, and then I have to go up 5. 1, 2, 3, 4, 5. So I'm going to put a dot right there. Okay, so that would be this guy. And then I'm going to do the same kind of deal here, except right now I'm going to go down. So I find the middle of these 2 guys, which is 3 pi over 8, and I'm going to go down 5. 1, 2, 3, 4, 5, and I'm going to put a dot right there. Okay, so there we go. And then I am just going to connect those so it looks like a pretty, oops, not so pretty, but you get the idea. There we go, sine curve. Okay, and oh my goodness gracious, so sorry about that. It's supposed to end right there. All right, so y equals 5 sine 4x minus 3. Ta-da, done. This is one of the questions that you really have to read through this several times, okay? Because I was a little lost at first. I was being silly and just wasn't reading it properly. But basically what they want you to do is they are giving you v of x right here. So that's the car's value, okay? X number of years since it was purchased. Okay, so this could change 1 year after it's purchased, 2 years after it was purchased, 3 years, whatever. And so then they give you Jacob and Julia. And Jacob and Julia each wrote a function that is equivalent to this original function. Okay, so they're just telling you, please just take our word for it. This is equivalent to this, and this is equivalent to this. Okay. Now, it says, though, whose function is correctly rewritten to reveal the approximate monthly depreciation rate. Okay, so this is a depreciation rate. We know that based upon the fact that this number right here is less than 1. So that means it's depreciating. But they want, this is, remember, go back here, it says X represents years. They want this to be written as a monthly depreciation rate. So what I did was I rewrote this equation right down here, but notice I have some spaces. Okay, so this is yearly. We want to make it monthly. What does monthly mean? If something occurs monthly, doesn't that occur 12 times? Like every month, 12 times in a year. Agreed? So 12 times in a year would mean this. So when I write that, this means 12 times a year, okay? And a year, because if we go up here, it says X is represented in years. Okay, so 12 times a year. Well, listen, you can't just throw a 12 in here and be done. Okay, you've changed the value of that equation unless you balance that 12 out. Okay, so the way I balance that out is to then take this 0.85 and raise it to the 1/12th power. Notice what I did. So if I put a 12 out here, I took its reciprocal and put it here. Now, why do I do that? Because hopefully you remember that when you have a power raised to another power, you multiply these. And if you do 1/12 times 12, that's 1. So 1/12 times 12 is 1. So this is really equivalent to 1x, which is what we had right here. Do you follow? So all I've done down here is change the look of this. It's still equivalent to that original function that they gave us. So again, I'm going to go back. It says monthly. That means 12 times a year. And then we can't just plop a 12 in there unless we do the reciprocal inside. Okay, so now what I'm going to do is I'm going to take my calculator and I'm just throwing this 0.85 to the 1/12 power. If you didn't get that, you can stop the video and try it in your calculator. See what you get. So that should be 33,400. And when I throw that in, I get 0.9865 to the 12x. And look at that. So that means Julia's function is correctly rewritten to represent the monthly depreciation rate. That's it. Number 31, we have to write a recursive formula. And I know when I'm writing a recursive formula, it's two equations. There's an a sub 1 and then there's an a sub n. Okay, well, a sub 1 is just the first term, which in this case is 8, so that one's done. Okay, now what we need to do though is we need to look at this and we need to figure out, is this arithmetic, meaning are we adding some number to 8, getting 20, and then adding that number again and getting 50, adding that number again and getting 125. So for example, if I add, the only way I'm getting to 20 here by adding would be if I add 12, right? But if I add 12 to 20, I'm not getting 50. And if I add 12 to 50, I'm not getting 125. So this is not arithmetic. This is definitely geometric, which means we're multiplying 8 by something to get to 20. And then we're multiplying 20 by that same thing to get to 50. Okay, so that's what we call our R. The easiest way I can tell you to do R is to just take your second term, which is 20, and divide it by your first term, which is 8. And that ends up being 2.5. Okay, that easy. Now, if you wanted to, you really could take your third term and divide it by your second term. That'll give you 2.5 also. It doesn't matter, but it's always a second term divided by its previous term, or in this case, the third term divided by its previous term. All right, so anyway, so since this is going to be recursive and we are looking at a geometric series, it's a sub n equals, and then it is a sub n minus 1, and then it just times the r, which is 2.5. There's your answer. All right, this question tends to be wordy, but it also tends to be pretty easy. You have to read it through. If you haven't read it through, pause me, read it through. And if you don't understand it, pause me again and read it through again. Read it through like 2 or 3 times. All right, so I've read it through and it's asking, is the mean weight of the grocery store's sample unusual? There's that word. And when we see the word usual and unusual, I'm always thinking, oh yeah, that's that mean plus or minus 2 standard deviations. Okay. Now, it says, is the mean weight of the grocery store's sample unusual? The mean weight, I'm just going to go right here, is 3.85 pounds. So that's the magic number right now that I'm kind of looking at. All right. I'm going to start by doing the mean minus 2 standard deviations. So that's 4.001. Look, I'm getting the numbers right from here. Minus, ignore the growly dog, 2 times 0.026. Okay, when I throw that in my calculator, I get 3.949. Then I'm going to do the mean plus 2 standard deviations. So that's going to be 4.001 plus 2 times 0.026. And that ends up being 4.053. All right, so that 95% confidence interval is 3.949 all the way up to 4.053. Okay, so hold on, let me write this. This is the 95% confidence interval. Okay, remember what that means. That means 95% of the data is in here. So if that number that they're asking, the mean weight of the grocery store's sample, if it's in here, that's a very usual occurrence. Think about 95%. That's a lot. Okay, anything being 95%, that's a high number of, like if we were talking about people, that 95% of people, that's a lot of people. It's most people. Okay, but if we're not in here, that is unusual. And let's look at the weight that we're looking at, 3.85. And 3.85 is not in here. So that is unusual. And you want to make sure that you give a written explanation. So this is what I have right here. Okay, 3.85 is outside the interval, therefore it's unusual. Another wordy question. So take your time and read them. Okay, pause me if you need to. All right, so they're saying that the probability that a guest room has a view of the lake is 0.24. And they say down here that we want A to be the event that a guest room has a view of the lake. So A is the lake, and B is the queen size bed. Okay, now if you also read the last sentence, it says events A and B are independent of each other. Remember that rule for independence, it's right here. Okay, that's on my little formula sheet, all those things you need to memorize for the regions. This is one of them. It says determine the exact probability that a randomly selected guest room has a view of the lake and a queen size bed. This is a symbol for and. View of the lake and a queen size bed. This is what we're finding. Well, we know what this is. They gave it to us. It's 0.24. And we know what this is. They gave it to us. It's 0.74. So all you really have to do then is just multiply 0.24 times 0.74, and that's going to give you the probability of having a lake view and a queen size bed, which would be 0.1776. There's your answer for the first part. Okay, the second part says determine the exact probability that a randomly selected guest room has a view of the lake or a queen size bed. Okay, that is also on that formula sheet with everything that you need to know for the regions. You need to study that. So we want the probability of a lake view. The or symbol is this. You can write the word or if you prefer, or a queen size bed. And that formula is the probability of A plus the probability of B minus the probability of A and B. All right, well, probability of A, again, they gave that to us. That's 0.24. The probability of B, they also gave us that. That's 0.74. And on the first part, we found the A and B. That's 0.1776. All right, so for the probability of A or B, we just throw all of that in our calculator, and that's 0.8024. There you go. Number 34, they're asking which function has the greater average rate of change. That's a fancy phrase for slope. Here's your formula. And they're asking to look at this slope on that interval from -1 to 4. So this is one of the x values, and this is another x value. Okay, now here is one function, m of x, and here's the other one, p of x. So they gave us a nice pretty table here. That's a little bit easier for most kids to start with, so I'm going to start there. All right, so they're talking about at x equals -1 and x equals +4. So if I'm doing the slope for m of x, so remember slope is really m, right? M stands for slope. For the slope for m of x, I would do y2 minus y1, so 81 minus 1 over x2 minus x1, so 4 minus -1. And then I just work that out. So that's 80 over 5, which is 16. Okay, now we want to know which one's greater. So what I'm going to do is I'm going to do the same thing. I'm going to find the slope now, but for p of x. Now that's a little, I don't want to say trickier, but it's a little trickier. We still know we're going to do 4 minus -1, but we don't have a chart for p of x. But that's okay because we have a calculator. So I'm going to just take this whole equation and I'm going to put it in my y1. 3 to the x plus 1. Just put that in your y1, and then you can go to your table of values. Okay, and you're going to go to your table of values and you're going to look for where x is -1 and you're going to look for where x is 4. Okay, so when x is -1, this is 1/3. I think it may be a repeating 0.3, which is 1/3. Okay, and 4 would be 81. All right, so here I'm going to do 81 minus 1/3. And I'm going to just throw all of that in my calculator. Now, depending, your calculator may give you a fractional answer. So if it does, that's the fractional answer. And if you want to compare it, just do 242 divided by 15 in your calculator, and that's 16.133. All right, now let's just compare which number is greater. This guy, right? Okay, so then you're just going to say p of x because 16.133 is greater than 16. For number 35, I plotted this point and I called it F because they said it was the focus, and the directrix is y equals 10, so this is the line y equals 10. They want us to write an equation for a parabola. Remember that if this is the focus and this is the directrix, the vertex or the turning point of that parabola is halfway in between. So there's 1, 2, 3, 4, 5, 6 spaces. So I'm either going to go up 3 from here or I can go down 3 from here. Okay, so then you're just going to do that. 1, 2, 3. There is my vertex, and I'm going to write V for vertex. Now, the next thing you ask yourself is, well, which way is this parabola pointing? Is it pointing up or is it pointing down? The parabola cannot be pointing up like this, like a U, because then it would be crossing the directrix. And remember, the parabola can never, ever cross the directrix. This is like a little force field. So this guy's got to be going down. All right, so I'm just going to, kind of draw that like that. Alrighty, so in that case, then I know that the vertex is -2, and then 7, right? -2, 7. And then the other thing we need to know for the equation is that P. Now remember, P is the distance from the directrix to the vertex, or it could be the distance from the vertex to the focus. It doesn't matter because they should be equal. So your P in this case is 3. Okay, all right, P equals 3. And again, this is in that formula sheet of everything you need to know for the regions. Got to memorize that. All right, now lastly, what's also on that formula sheet is the formula for the equation of a parabola. So it is y equals 1 over 4p, then x minus h, that quantity squared, plus k. So here we go. We know that our p is 3, right? So 4 times 3 is 12. However, notice that this parabola is going down. So this 1/12 has to be negative because the parabola is going down. So don't just write 1 over 12. You must stick a negative in there. We'll make that nice and dark so you can see it. All right, the h and the k are really just the coordinates of your vertex. But just remember, anything inside parentheses, you always change the sign. So the x coordinate is -2. And because this is in parentheses, then I am going to be writing +2. The k is not in parentheses, so since that 7 is just 7, I just write +7. And there's your answer. We are going to find the zeros, which basically means we are going to factor. And since there's 4 terms, I group the first 2 and I group the second 2. So out of the first 2, I notice that they have a common factor of x squared, which leaves me with x plus 2. And then in the second grouping, I see 2 negatives there. So I'm going to take out a negative and a 16, and that will leave me with x plus 2. Now they want the zeros, which means that I'm going to take that and set it equal to 0. All right, so I'm going to take the 2 GCFs, which is the x squared and this -16, and they get put together in one set of parentheses. And then that common term gets represented in the other set of parentheses. Okay, please be careful. X squared minus 16 is the difference of 2 perfect squares. So that can be factored to x minus 4 and x plus 4, along with that x plus 2. And there's your factors. Now, it's not asking us to factor, it's asking us to find the zeros. So we got to go one more step. Change the sign, change the sign, change the sign. And those are your zeros. Easy peasy, right? All right, now the second part asks us to sketch that graph. All right, so 1, 2, 3, 4, that's one of my zeros. 1, 2, 3, 4, that's another one of my zeros, and -2 is the other one. All right. I know that I have a cubic function. So when I have a cubic, I'm just going to sketch this off to the side here. My cubic could go 1, 2, 3 direction changes. That's a cubic, right? The highest power is a 3, so we have 3 direction changes. Or it could go down, up, down like that. Okay, so again, a cubic, 1, 2, 3 direction changes. Cubic, 1, 2, 3 direction changes. So which one is it? Let's go back and look at the original function. Your leading coefficient, in other words, the highest power, right here. Look at the number that's in front of there. You see that it's a positive 1. So a positive 1 means it goes up first. So it will look like this. If this had a negative in front of it, then it would be this guy, because look, we are going down first. So we read from left to right. Okay? All right. So here we go. We are going to go up first. So that means I'm going to go up like this. Okay. All right. So I'm going up like this. Now I am turning and going back down like this. Okay. And then I go like this. And that's not the best picture in the world. But there we go. There's your C of X. Okay, this is 4. I'm going to put some kind of a scale there just so that whoever grades my regions will know that I'm counting by ones here. And I always like to just throw that in there. And you can look at that in your table because you can just easily take this equation and put it in your Y1 and get a graph, right? And if you go down to when X is 0, you will see that this is at negative 32. Okay, so let's look at the first part. It wants us to write functions for A of t and B of t. That's what it's asking for right here. Here's the general formula that we're using. Colony A starts with 10,000 bees. Growth rate of 0.25, so that would be your R. Okay, so these are exponents, 0.25t and E. And please make sure you write it as A of t. Both A of t, okay, and B of t. So here's B of t. Initial population is 6,000 bees. E, and we have a growth rate of 0.45 t. So there's your first part. Again, you must have A of t equals and B of t equals, and these must be t's. Now it asks us to graph them. So all I did was I put this in my calculator, in my Y1, and you can go to the table. That would be fine. If you want to, you can also change your window because we have to get all the way up there past 10,000. I mean, if you look at this, we're going to be going up to like 40 something, like about 40,000. So you would make your Y max about 40,000. Okay, and then you could graph it and see it, or just go to the table. When X is 0, I'm just looking at look at the A of t. So when X is 0, I am right here at 10. When X is 1, when X is 2, when X is 3, and when X is 4. There's no need to do more than that. Okay, and then I just connected these. And then I did the same thing with B of t. So I put this in my Y1. I went to the table, and again, when X is 0, 1, 2, 3, and 4. All right, we're going to be referring back to this graph to do the next set of questions. Okay, so for the state to the nearest tenth of a month, when the colonies will have the same population, basically we want to know where they're equal to each other. And if you look at the graph, you can take a guess, but we don't really know specifically. We know it's somewhere between 2 and 3 if you look at the graph, but we need a specific. Well, if you put the A of t equation in your Y1, and you put the B of t equation in your Y2, and do what I had said before, change your Y max to about 40,000, okay? And then you can see where the two graphs meet. And then from there, listen to what I'm saying. If you have the calculator in front of you, this should not be difficult. You hit second, trace, which is your calc button, and then you just go down to number 5, I think it is, right? Let me see, second, trace. Yep, number 5, intersect. Okay, go to the left of the intersection point using your left cursor button. Hit enter. Now go to the right of the intersection point using your right cursor button. Hit enter twice. And when you do that, you are going to end up getting t equals 2.5541. Okay, and they want you to round that to the nearest tenth, which is 2.6. and it would be months. All right. It really is helpful if you pause me, rewind me, and you have to practice it in your calculator, because if you don't, you're really not going to know what you're doing when push comes to shove and you have to do it on your own. Okay? All right, so the last part here, it says determine algebraically how long it will take to the nearest tenth of a month for the population in colony A to triple. So I'm going to start with colony A, and I'm going to look at its equation. Now, if something triples, and I started with 10,000, that means I will end with 30,000. I started with 10,000, and I want to find out how long that takes. Well, that's solving for t. So I'm going to start by dividing out by 10,000, dividing out the 10,000, I should say. So that's 3 equals e to the 0.25t. Okay, so let's think about this. We had something similar earlier on in the regions. We're trying to find an exponent, right? And we can't find t if it's an exponent. We have to bring it down. So what we did earlier is we logged both sides, but we have an e here. So if we have an e, we ln both sides. And then this is going to drop down right in front there. And remember, the ln of e is 1, so that is just going to really cancel out. Okay, so whenever you have an e, you ln. If you don't have an e, you log. So we're going to have the ln of 3 equals 0.25t. Technically times the ln of e, but if you put the ln of e in your calculator, you're getting 1. So there's no reason to write it. So I'm just going to now just solve for t. And I'm going to put that in my calculator. ln of 3 divided by 0.25, and I will get 4.3944. And they want this to the nearest month, so that's 4.4 months.